All right, let's talk about how to find all of the roots for this function. I've graphed it off to the right there, and what I can see is that I'm going to make a list of my roots here. I have a root at 1, so x equals 1. Now remember, I can write that as x equals 1, or I could write it as an ordered pair. Either one's fine. I need to find that the remaining 2 roots. So to do so, I'm going to do my my division of polynomials. So I'm going to use my box method here for doing this because I find for you guys it tends to be a little bit easier that way. And I've got my polynomial that I'm going to write here at the bottom. So x cubed plus 9x squared plus 31x minus 41. And then just start setting this up so that I can find the division. Now, I'm dividing by the factor that results in the root of x equals 1. So that factor is going to be, I'm going to move this down a little bit, x minus 1. That's what would give me a root at x equals 1. So that's what I'm dividing by, is x minus 1. Now I've got to figure out what's going to be the quotient. So I start out with the x cubed, and I know that in order to get x cubed, when I multiply something by x, I will have to multiply by x squared. And then I can multiply x squared by -1 to get negative x squared. Now I know that these 2 boxes have to add up to 9x squared. So that means this has to be 10x squared. All right, and then I can start the process again. Something times x gives me 10x squared. That's going to be 10x. Okay, and then I have 10x times -1 is negative 10x. And then once again, I know these 2 boxes have to add up to 31x. So I'm going to have to add 41x here. And then finally, I know that x times 41 will give me 41x. Negative 41 is what I would have there. And then I don't have to add anything. That gives me, my remainder is 0. So I know that I did the division properly because I don't have a remainder. All right, so now I've got this quadratic, and I'm going to use that quadratic right here, and I'm going to solve now as if that quadratic is set equal to 0. So 0 equals x squared plus 10x plus 41. Now you could try factoring this, but chances are, in looking at the graph as well, we see there's only one place that this function crosses the x-axis, so there's probably only one real root, which means we aren't going to be able to find the other 2 roots by factoring. We're going to have to use the quadratic formula. So if I do so, I'm going to have x equals -10 plus or minus the square root of 10 squared minus 4 times 1 times 41 all over 2 times 1. Okay, so that's going to be x equals -10 plus or minus the square root of -64 all over 2. And then we can work on simplifying that. So to simplify that, I'll have x equals -10 plus or minus. Now the square root of -64, hopefully you can remember that's just going to be 8i over 2. And then, we can think of this as -10 over 2 plus or minus 8i over 2, which is just going to be -5 plus or minus 4i. So our other 2 roots are -5 plus or minus 4i. And this is what I was asking you for as an answer. If I had asked you to factor it, well, then you would have just written that quadratic here because that can't be factored using integers.